Welcome back. Let's talk about another important concept: immutability. Immutability means not changing the data, not changing the state. Remember how in object-oriented programming we had classes that, well, you can change the name property, the weapons of the characters that we're building? Well, in functional programming, the idea is of immutability. That is, not changing state, but instead making copies of the state and returning a new state every time. For example, we have an object here, a simple object with a name of Andre. If I create a function that clones an object, and I'm using here a function that is pure. We're not doing anything here except cloning the object. So no matter how many times I call this function, it's going to clone. It's a pure function. But afterwards, I go ahead and do object.name in my program and update the name to Nano. And as you can see here, as soon as I do that, the name gets changed to Nano. And this, well, this is mutating the state. We're mutating data in our program. In functional programming, the idea of immutability is very important. We can change things inside of our function, but we don't want to affect the outside world in our programs. And although this function is pure, well, our program has a lot of immutability to it. Ideally, if we wanted to change the name, we would create a function saying change name. Or let's do update name that receives an object. And in here, we will have a new object. Let's say object2 that we clone the initial object from that we receive. And in here, we can do object2.name equals Nano. And then finally, we can just return object2. Let's see that in action. If I console log the original object here, and up here, I'll do update name and give it the initial object, and I click run here, I see that my original object, which is Andre, is still there. But if I create a new variable here saying updated object, and I console log the updated object as well, I see that there are two different things now. I've maintained immutability of not changing the state, just returning copies or new things every time a change is made. Now, you might be asking yourself, this doesn't seem very memory efficient. I mean, this is a silly example, but if we're just copying things over and over every time we want to make a change, doesn't that just fill up our memory? Now, this is a little bit beyond the scope of this course, but there's something called structural sharing that when it comes to functional programming, a lot of places implement. And it looks something like this. The idea behind it is that when a new object, or let's say an array or any sort of data structure is created, we don't actually copy everything. If it's a massive object or an array, you can see that being very expensive. Instead of storing the entire copy underneath the hood, what happens is that only the changes that were made to the state will be copied. But the things that don't change in memory are actually still there. And this is called structural sharing. This, combined with the fact that in this day and age, memory is fairly cheap, it makes sense for some cases in functional programming where we have immutability. Because by having immutability, we can do some really interesting things that we're going to see when we finish our coding challenge from the beginning of this section. We're simply saying, hey, this data is not mine. Any data that I receive is not mine. So I'm just going to borrow it, and I'm only going to copy and make a new copy of this data so other people can still use this. It's kind of like kindergarten, right? If you played with a toy, well, you shouldn't destroy it. You shouldn't change it. You should play with it and then return it back to the school so that other kids can play with it too. Let's take a break, and I'll see you in the next video.